Hi students, today we are going to see the topic solutions. Solution means a mixture of solute and solvent. So solute plus solvent which gives solution. Solute means the substance which is going to be dissolved in a water or any other solvent, and in solution the compound, the percentage is very less in weight. Solvent means the substance which dissolved the solute, we call it as a solvent. So solute plus solvent gives solution. A solution is a homogeneous mixture of two or more substances. That means, example, salt is a solute and water is a solvent. So salt plus water which gives salt solution. After the formation of salt solution, so it gives a homogeneous mixture only. That means we cannot separate into salt and water. It is not a heterogeneous layer. So it is a homogeneous mixture of two or more substances. In a solution, if the component present in lesser amount by weight is called a solute, and the compound present in the larger amount by weight is called a solvent. So in short, we can say a solute plus solvent which gives solution. Example, salt water that gives salt solution, or any chemical salts. For example, copper sulfate when dissolved with the water to give copper sulfate solution, or sugar solution. So these are the examples for solutions. A solutions is a homogeneous mixture of two or more substances. The solutions may be classified into three types. One is a true solution, second a colloidal solution, and the third one is suspension. First I will explain that. A true solution means the particles after dissolving in a solvent which gives a clear solution, and the particles never settle at the bottom. They are called as true solution. Second, colloidal solution. Suppose if we dissolve a starch powder, that is kanji powder, and water, we get a cloudy mixture. This mixture we call it as a colloidal solution. And also a wheat flour mixed with the water, it gives a turbid mixture, and fine particles slowly settle down at the bottom after some time. This mixture is called a suspension. So solutions, if the particles are completely dissolved and gives a clear solution, means it is called a true solution. And if it gives a cloudy appearance, that means as a dull solution, it's a turbid formation, it means it is called as a colloidal solution. And if the particles do not dissolve and settle at the bottom, we call it as, for example, if chalk powder, if we dissolve in water, or wheat flour, if we dissolve in water, means it is settled at the bottom. That type of mixture we call it as a suspension. Now, what are the differences between solutions, colloids and suspension? So the major difference is the particle size. As fact, interconventions for these mixtures are possible for varying the particle size by certain chemical and physical methods. Now, the main differences between the types of solutions, that is true solution, colloidal solution and suspension, how it varies. Very important question. So if the particle size is less than 100 nanometer, that means is more size, that is the size of the particle is very large, means it comes under suspension. If it is 1 to 100 nanometer, that is nm means nanometer, it is called colloidal solution. And if less than 100 nanometer means it is called solution, that is true solution. Then filtration. After formation of clear solution, whether it gives it can be separated by filtration process, means it is possible, here impossible, and true solution it is impossible. Setting of particles. In suspension, it is settled on their own, that means remains settled down. Here settled on centrifugation only, and do not settle because it gives a clear solution. Then appearance, it is opaque in nature, that means when light is passing, it does not reflect its light on the other side. So opaque in nature. Here translucent or semi-transparent, that is half of the light will be seen on the other side. Transparent means just what is shown that side, means it is clearly seen in the next side. That is called transparent. Then Tyndall effect. I will explain the Tyndall effect later. just you know this one, shows, that means it obeys Tyndall effect. Here colloidal solutions also shows Tyndall effect. Here true solutions does not show Tyndall effect. So I will explain later about the Tyndall effect as well as Brownian movement. Then diffusion of particles, it do not diffuse. Here diffuse slowly, here also diffuse rapidly. The nature, it is a heterogeneous, and it is a heterogeneous, and a true solution alone is a homogeneous. So the difference between suspension, colloidal solution and a true solution is very, very important detailed answer. Now I will explain what is Brownian movement and Tyndall effect. Brownian movement. So these two effects does not seen by true solution particles, because the particle size is very, very, very smaller in size, and they give a clear solution only. It is a homogeneous. So these two effects, Brownian movement as well as Tyndall effect, does not shows by the true solution. So when colloidal solutions are viewed under powerful microscope, that means it can be seen that colloidal particles, they are moving constantly and rapidly in zigzag directions. So before that I want to say one thing. Brownian, that is one Robert Brown, he is a botanist. When he mostly used to sit on the banks of the river. At that time he saw that the pollen grains from the flowers, that is trees along the banks of the river, so the pollen grains which are spreading on the rivers, it is not placed in one position, so it is moving randomly here and there. That is called as a zigzag position. Similarly, in the colloidal solution also, since the particle size are somewhat bigger, so it does not place in one position, it is moving here and there in a continuous random zigzag motion. That movement of the particle is due to the unbalanced bombardment. That means one molecule can combine with another one, it is bombarding with each other, so it forms a continuous movement. So such a movement is called as a Brownian movement. So when colloidal solutions are viewed under powerful microscope, it can be seen that colloidal particles are moving constantly and rapidly in zigzag directions. They are Brownian movement of the particle is due to the unbalanced bombardment of the particles by the molecules of the dispersion medium. So next I will explain about the Tyndall effect. In Tyndall effect, before that I will say one thing. Suppose if you are staying in a closed room, that is full closed room, sunlight is not allowed to enter into the room, but one small hole is there in the window side. So through that window the sunlight will be passing. Suppose if you are seeing the way of sunlight entering into the room, it shows some dust particles are moving here and there. Such effect we call it as a Tyndall effect. And also when we are traveling in the two-wheeler or four-wheeler, during night, in front of the light, some insects or some dust particles which will be moving here and there, we saw. So this is due to the scattering of light, that is called as a Tyndall effect. So Tyndall is a scientist, he observed that when a strong beam of light is focused on a colloidal solution, of the part of the beam becomes visible. That is, when the strong beam of light is focused on a colloidal solution, the path of the beam becomes visible. So this phenomenon is known as Tyndall effect. So this phenomenon is not observed in the case of true solutions. So what is Tyndall effect means? The beam of light coming from headlights of the vehicle is also due to Tyndall effect, and the blue color of the sky is also due to the Tyndall effect. Now here is a tabular column which shows that the classification of colloids. That means dispersed phase means it is called a solute. Dispersion medium means it is called a solvent. Suppose if a solute and the solvent is both are solids means it is called as a solid sol. Example is alloys, germs, colored glass, etc. Alloy means two or more metal. So both the metals are solid in nature. So if any two particles both are in solid nature means, and if it gives a homogeneous mixture, we call it as a solid sol. Then second one is solid liquid. Solid when dissolved with the liquid. For example, paint, ink and egg white. Third, solid gas, that is aerosol, smoke and dust particles. Example, liquid in solid, gel formation, curd, cheese, jelly. Liquid in liquid, emulsion, milk, butter, oil in water. Example, liquid in gas, aerosol, mist, fog, clouds. Example, gas in solid, the solid foam, cake, bread. Gas in liquid is a foam, soap, lather, and aerated water. So these are the types of colloids based on their physical state, that is dispersed phase and dispersion medium. So there are 8 types are there: solid, 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 liquid, solid, gas, liquid, solid, liquid, 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 gas, gas, solid, gas, liquid. But gas in gas is not possible because it is a combination. That means if the mixture of gases means it is forms a true solution. So gas in gas is not possible. The last topic of this chapter is emulsions. Emulsion means what? An emulsion is a collide of 2 or more immiscible liquids where one liquid is dispersed in another liquid. For example, if we take milk, butter, cream, egg yolk, paint, cough syrup, facial creams, pesticides, etc. For example, if we take the normal you are using no daily purpose, that is facial cream that is Fair and Lovely or Vaseline. Here the liquid particle also present as well as oily particle is also present. So if both are present and you use a mixture, we call it as an emulsion. So an emulsion is a collide of 2 or more immiscible liquids where one liquid is dispersed in another liquid. This means one type of liquid particle gets scattered in another liquid. So emulsion is a type of mixture made by combining 2 liquids that normally don't mix, but both are mixing, but not completely mixing or reacting. So the process of turning a liquid mixture into an emulsion is called emulsification. Example, milk, butter, cream, etc. Now the types of emulsions are, there are 2 types. One is oil in water emulsion and second one is water in oil emulsion. That is, oil in water means water is maximum amount and oil is little one. Water in oil emulsion means oil is maximum and water is very little. So the 2 liquids mixed can form different types of emulsions. For example, oil and water can form an oil in water emulsion. Example, cream. With oil droplets are dispersed in water, or they can form water in oil emulsion. Example, with that is butter. With water is dispersed in oil. So here these emulsions can also find applications in food processing and in medicines, that is pharmaceuticals, metallurgy, and many other important industries. The chapter in chemistry, the chapter number is 10 is over. That is matter around us pure is completely over, theory part. The next week I will explain about the textbook exercises, and then we will continue the next chapter in the physics. So very important lesson in this. So understand well and write as a home test also.